In number 41, your caustic for surface area of a pyramid, we're going to find the surface area of the composite figure. So in order to do that, we're going to find the area that's given by the four triangles around the top pyramid. So we'll call this the pyramid area. So that'll be, now we have to look at the base. So we don't have a square pyramid anymore. We have a rectangular pyramid, which means that we're going to have to find two separate slant heights for the triangles here. So there's going to be two new slant lengths that we're going to utilize, which gives us two different areas for these triangles. And since we have this triangle in the front and this triangle in the back here that have the same area, we'll say 2 times area 1 plus 2 times the area of the opposite triangle. That'll be area 2. We'll give the area around the pyramid. So expanding this, now we have to find the slant heights. So finding the slant height of this one first. That one we can construct a right triangle to the center of the pyramid, and we can say that it has a length L given by a Pythagorean theorem. So that'll be the square root of the two sides squared added together. So that's 1.5, which is 3 halves squared, plus now this base edge is given by half of this side length, which is half of 2.5, and 2.5 is written as 5 over 2, so half of that would be 5 over 4 squared, giving us square root of 9 over 4 plus 25 over 16. Now we can convert 9 over 4 to multiplying by 4 over 4. That'll give us 36 over 16, and then we're adding 25 over 16, so we can combine that to a single fraction. That'll be 61 over 16, all under the square root. So pulling 16 out from under the square root, we have square root of 61 over 4 as the slant height for this triangle. So the area of that triangle will be 1/2 of its base, which is given by this length here, 3 feet, times its slant height, which is square root of 61 over 4. Now we have the area of the other triangle given as 1/2 of its base, so that'll be 2.5, which is 5 halves, times its slant height, and we'll call this S. So finding S, we have the square root of constructing a triangle here to the center. We have a one side length of 1.5, so that's 3 halves squared, plus this base edge is half of 3 feet, so that's also 3 halves squared. Now we can simplify this to 9 over 4 plus 9 over 4, which is square root of 2 times 9 over 4. Pulling out 9 over 4 from under the square root, we have 2 over 3 square root of 2 as our length for S. So plugging that back into here, we have 3 over 2 square root of S for the area of that triangle. Now I can solve this out, so cross out a half and 2. Now we have 3 square root of 61 over 4, plus, cross this out, we have 15 square root of 2 over 4. We can combine that to one fraction. We'll have 3 square root of 61 over 4, and then plus 15 square root of 2. And there's really no way of simplifying that further because 61 doesn't have any multiples. What's left is the lateral area of the base rectangular prism. So that lateral area is given by twice the area of this front rectangle, because we have that in the front and in the back. So that'll be 2.5 times its height, which is 2. So that's 5 halves times 2, which gives us 10. And then we also have twice the other area, for this rectangle here, so that has an area of 3 times 2, and 3 times 2, which is 12. So we have, let's see, 22. Now we have the surface area given by the lateral area plus the base area plus the pyramid area. So we found the lateral area is 22. We have the base area. Base area is 3 times 2.5 because we have a surface underneath. So 3 times 2.5, which is 5 halves, is 15 over 2. So we add 15 over 2 plus the pyramid area, which we found as 3 rad 61 plus 15 rad 2 over 4. And we can put all of these numbers over 4, so we have a surface area of 22, rewritten as something over 4, will be 88 over 4, plus 15 over 2 is rewritten as 30 over 4, plus 3 rad 61 plus 15 rad 2 over 4, and we can combine that into one fraction, all over 4, and that'll be in feet squared.